Hi, everyone. Getting to the pointy end of term now. I think everybody has their mock exams within the next few weeks, and then you've got 2 weeks of term 4, and then your external exams start. I was going to continue with our exam prep, but there's one thing that hasn't been taught, and is never taught well, and that's redox reactions. Anybody remember what redox reactions are? No one? So redox reaction is a reaction in which we have oxidation and reduction occurring, or there's a transfer of electrons. We're going to go through from the beginning to the end of the process. Probably take the better part of half an hour, not longer than that. But there's a set of steps that's required, and that doesn't change regardless of what the reaction is. So we're looking at reactions where there's been a transfer of electrons between a metal and a non-metal. One species is oxidized. You'll all remember this, and I want everyone to write it down. Anyone remember what oil rig stands for? No one? So oxidation is loss. Oh, never mind. Oxidation is loss. Reduction is gain. Here we're talking about the loss or gaining of electrons. Oxidation and reduction. So I want everyone to write that down, and then we're going to get into it. Firstly, we're going to remember our process for assigning oxidations. Not going to go through every single rule in great detail, but the ones you need to know. Last year's exams, I think we calculated 10% of your mark was with regards to this stuff. A couple of short answer and a long answer, as well as a couple of multiple choice. So if you can understand this process, you're looking at a decent chunk of your marks. So oxidation state, or the charge on an atom when it's bonded with something. If something is an elemental state like O2, and you know what the charge on any atom that's in its elemental form is. Any ideas? Zero, yeah. What about on oxygen? If we've got H2O, what would the charge on oxygen be? So oxygen is always -2. H is always +1, but because there's 2 of them, it balances. And all the way back to grade 9 when you were naming compounds. Anything in group 1 is +1. Donates 1 electron. What about group 2? +2. Group 3. +3. Group 4 can go either way. Group 5 is -3. Group 6 is -2. Group 7 is -1. So write that down, take 25 seconds. All right, this will all make sense, maybe. Where's that? So we're going to look at this reaction here. So we have, and some of you might have done it with me before, forget you about me. It's a classic one, it's nice and simple, but doing it more won't hurt. So MnO4 minus gives us Mn2 plus. So we'll write that down. What I want you to calculate is what's being oxidized and what's being reduced. So I give everyone 2 minutes. What's being reduced and what's being oxidized? So in order to figure that out, you need to figure out the oxidation states of the atoms, or just one of them. And that'll tell you the other one. All right. Anybody want to hazard their opinion on this one? Doesn't matter if it's wrong. So what's the oxidation state of iodine here? So it tells us it's -1. What's the oxidation state of iodine in its elemental form? It's going to be 0. So iodine is losing 1 electron. Manganese over here is 2 plus or +2. Go back on this side. Manganese over here, we have to calculate in a slightly different way. Oxygen is -2, and there's 4 of them. So oxygen's overall charge on all of them is -8, because each one is -2. There's a 1- charge on permanganate here. So to balance that, we would need to have manganese as a +7. So if we look at it, manganese is going from +7 to +2. So it's gaining electrons. And you guys need to be copying this down as I'm doing it, step by step. Okay, so we write out our oxidation. Our oxidation half reaction is I minus. We write our our reduction half reaction as gives us Mn2 plus. What do we know about chemical reactions? What do they need to be? Balanced. So we place a 2 in front of our iodine. The manganese down here is balanced, but the oxygen isn't. So what needs to change there? What can we add to this to balance the oxygens? Remember, we're balancing this in an acidic solution. So what we can do, solution being in water, is we add 4 H2O. Now our oxygens are balanced. And I'm going to give you guys 60 seconds to tell me how I could, because this is an acidic solution, how could I balance the hydrogens now that the oxygens are balanced? What makes a solution acidic? Hydrogen ions. So we could add 8H plus. So is that balanced now? So it's balanced. So what's the problem here? How many electrons are being transferred in the oxidation reaction? So we've got 2 electrons being transferred here. And here we're going from +7 to +2. So we have 5 electrons being transferred. So anyone want to hazard a guess as to what we need to do to balance the electrons being transferred? So what I want you guys to do is common denominator, or the nearest number between 2 and 5 would be 10. So everything in this top reaction times it by 5. Everything, including the iodine, everything. Down here, we've got 5 electrons. We need to make it to 10. So times everything by 2. So whilst I'm doing this, you guys are capable of multiplying by 2. Yeah. So now we add in our electrons, 10I minus to 5. Ten electrons. The reduction then becomes 10E minus. Gives us well, we got 8H12. So I want you guys to write that out, and I want you to tell me and make sure that my equation balances. So again, another 60 seconds or so. Balanced. So 10 iodine, 10 iodine, 16H plus, 16H plus, 2 MnO4. So what we can do, because now we need to combine these again, because we split them into the 2 reactions, we get rid of anything that's on the same, or we cancel out anything that's the same on both sides, including the electrons. So we get rid of the electrons now because they balance. So we're going to put this reaction back together. We start with what's being oxidized. 10I minus. 16H plus. And we've got our that gives us, so again, now we have to do a number of things now. So does that balance? I want someone to answer. Does that balance? Do the atoms balance? That's the first thing we check. So on this side, we've got 10I. On this side, we have 10I. This side, we've got 16H. This side, we've got 16H. This side, we've got, sorry, it's meant to be 2 Mn2 plus. That's why we check. That's why we balance. Got 2 Mn over here, 2 Mn. Then we have 4O and 4O. So we've checked, it balances atomically. But what we also need to balance is the charge on both sides. So we go back to grade 8 maths when we learned about the negative number laws. So we have 10 minus plus 16 plus 2 minus, which gives us plus 4. Over here, we've got 0. 2 times plus 2 is plus 4. And we have 0 because there's no overall charge on those molecules. So we know it's balanced. We know it's balanced in an acidic solution because we have H plus. You'll know from when we looked at, or when you've looked at electrolytic cells and electrochemical cells in class, that they can occur in a basic and an acidic solution. Who remembers their acid and base chemistry? What makes a solution basic? So what can we do to make this solution basic? H3O is the acid. OH minus is the base. So we can add hydroxide to it. So we need to balance the H plus with OH minus. So I'm going to rewrite the equation or the formula, whatever you want to call it. reaction. So now we're balancing in basic solution. In order to balance in the basic solution, we have to balance in the acidic solution first. Oh, I'm supposed to leave a gap. So we would add 16 OH minus to both sides because we need to counteract the H plus here with 16 OH minus. Just rub that out. So we plus 8H2O plus 16 OH minus. All right, rewrite that equation. So what amount I need to work on writing straight? We've added 16 OH minus to this side to neutralize the acid of this side. And in order to do that, we have to add it to both sides. So give everyone 30 seconds to just note down the equation now. So the first step is balance the OH minus on the left. So balance the H plus on the left with some OH minus. All right. So what do we do next? If we add H plus and OH minus, what do we get? Water. So next step, let me get rid of this down the bottom. So we're neutralizing the H plus with OH minus. So now it's 16 H2O. So we now know this is a basic solution because over here we have 16 OH minus. Over here, we have no more H plus. We have an excess of OH minus. Is there anything we can cancel out that's on both sides? Well, so what we do is we 86 the water over there, RIP in peace. So we end up with, as our balance equation, so plus 8 H2O, because we've cancelled out 8 of them. They can't just disappear. I haven't left myself enough room to write this again. The same thing, you guys have got 60 seconds now to tell me if that's balanced atomically and are the charges balanced on both sides. So we've got 10 iodine, 10 iodine, 16. We've got 16 oxygen molecules on both sides. We've got 10 minus plus 0 plus 2 minus. So we have a 14 minus charge on this side. We have 0. We have a 12 minus charge on the left-hand side. I can't count. Plus 0 plus 2 plus, but there's 2 of them, so it's a 4 plus. So we have 12 minus on both sides. So now our equation is balanced in an acidic and a basic solution. Right. Let me go for time. So we're going to do another one. And well, I'm going to start you guys off, and then I'm going to leave it to you for your homework. So this one's a little bit more complicated, but the numbers are effectively the same. So we've got sulfite plus, it's same, but different. Remember that. All right. I'll give you guys 60 seconds to figure out what's being oxidized, what's being reduced. All right, anyone want to put themselves out there? So again, we go back to our oxidation state calculations. Here, we calculate oxygen first. So there's 3 of them. So it's -6. We have a 2- charge, so sulfur would need to be +4. We remember from our manganese before, manganese +7, oxygen -8, but there's a -1 charge. So here, oxygen has a -8 overall charge because there's 4 of them. Sorry. Sulfur has a +6 charge. Manganese, well, it has a +2 charge. So I've done the hard work for you. Which one's being oxidized? Which one's being reduced? Anyone? Want to hazard a go? So remember, Kai, it's not the whole molecule that's being oxidized or reduced. It's, in this case, it's just sulfur, which is being oxidized. Manganese is being reduced. Yeah. So sulfur is being oxidized because it's going from +4 to +6. Manganese is being reduced because it's going from +7 to +2. So our oxidation reaction is So what do we have to do to balance? How do we balance the oxygen in the oxidation reaction? So we add H2O. So now we've balanced the oxygen, but what is unbalanced? So our hydrogen, so we can add 2H+. Remember, it's an acidic solution first. So our reduction reaction, same as before. So we got MnO4 minus 2. Yeah. We got MnO4 minus. What do we got? Plus. And that's where I'm going to leave this with you guys. And then next week, or if you want to send me your answers, following the same procedure that we followed for the first one, and then we'll pick this back up next week once you guys have had a go. I'm going to organize a bunch more recordings in week 9 and 10, where we'll catch up from when my voice was destroyed at the beginning. I've got some practice exams, questions written that I'm going to take you guys through. I like to predict what's going to happen on the exam. Last year, I was pretty close for most of the questions with roughly what they'd be assessing. So fingers crossed I can get it close to being right again. But I want you guys to take that to being balanced in an acidic and then a basic solution. Once you've written that down, I'll give you 20 seconds, then we'll be done. All right, I will see you guys next week.